Okay, so today is our last lecture of Unit 4. I will have the Unit 4 test sent out to your location later today. We will only take the class period on Monday to work on them, but as always, you'll have whatever time you need beyond class period to work on those. So please feel free to take that time. Also remember, if you have extra time, corrections on Test 3 can still be completed. Even there's a couple of you with Test 2, if you still want to work on those as well, you can do those and turn those in as well. And remember, for corrections, you get half your points back, so it's well worth your time to do that extra work to get those points back. You can work with your classmates, you can work with other teachers. If you want to, you can talk to me, and I can try to take time at the end of class, or we can schedule a Blue Jeans session outside of class that we can log in, and we can look it over as well. So with that, like I said, we've got a few small topics to finish up for Unit 4. A couple of them are things that you've all seen, but I wouldn't feel right putting them on the test if we didn't go over them. And that's what this first one is. And we're looking at data graphs. And this is one of those topics that I go back and forth on whether it's really part of Unit 4 or Unit 5. Unit 5 is statistics. And of course, data graphs display statistical information, but they display the raw data before it's really processed. So we're going to include it in Unit 4. And so data graphs basically are a way of organizing raw data. For example, let's say that we were looking at changing school colors. And we had choices between red, blue, and green. And we surveyed students to see what they preferred. And we're just going to put down their response as R, G, or B. So let's just look at those 20 responses right there. If I asked you to look at those and tell me what was the most common response, it would be tough to do. In fact, the brain, human psychology tells us that the human brain can take in between 7 and 13 things at once before stuff starts to blur out around the edges. So here it really would depend on where you were looking. If you were looking like right in here, you would say red appears to be the most common. If you're focusing here, you'd probably say blue appears to be the most common. If your focus was down here on the right end, you'd probably say green. Well, let's look at what really is the most common. One of the ways we can organize these is in a table, and the technical term for it is called a frequency table. So in one side of the frequency table, we list the categories, in this case, the color. We have red, blue, and green. And then here we're going to list the frequency. In other words, how often each of them was chosen here. Now you'll notice one thing, I was very careful to make this in black, one of the colors that is not one of the options, because having extraneous colors in there, and we talked about that human psychology thing a minute ago, that's another thing. When we display data, we try to make sure we take human psychology out of it, that psychological response. If I had different colors in here, your brain might latch on to one of the visual colors rather than one of the words for the color. So for red, I am going to use a color to cross those off. I've got 1, 2, 3, 4, 5, 6, 7 red. Which, that makes sense out of, oops, all the way to the bottom on me here. Let me get all the way back. Out of 20, having 7 red, that's about right. For blue, 1, 2, 3, 4, 5, 6, 7 blue. So 7 blue, and then for green, 1, 2, 3, 4, 5, 6 green. And of course, we can add those up to get a total of 20. looking at the raw data, you never would have guessed that they were that close to the same. Now, if we were going to graph these, one of the ways we could display them is a bar graph. In a bar graph, we could either list the colors along the bottom or up the side. It doesn't matter. I'm going to list them along the bottom here. Statistically, we tend to do vertical bar graphs so that the bars go up and down instead of side to side. Gross red, blue, and green. Now up the left side, I need a scale that encompasses our highest number. Well, this only goes up to 7. So I'm just going to go 1, 2, 3, 4, 5, 6, 7. So my bar for red has to go up to 7. For blue has to go up to 7. And for green has to go up to 6. Now again, I made sure I made those bars all the same color, and none of the color is not any of the colors themselves. Other things I tried to do here, I maybe didn't do such a good job of, but I tried to make all the bars exactly the same width. So that again, that human psychology effect that we didn't see a wider bar, so it takes up more area, so that our brain perceives it as larger than the others. I also attempted to keep the same amount of space between them because again, 2 bars closer together, your brain might perceive them as smaller or larger because of their proximity to each other. I didn't do a great job here of that, but it's very important to do that. Now, something we'll talk about a little bit more in Unit 5 with statistics, because these are categories down here and not numbers, that's why we have space between the bars, because there is no logical link from one color to the next. So we have space between the bars to show that there is a gap. There isn't a link. No visual link between the bars indicates no actual link between the categories on bottom. Now, the second type of graph we could use to display these would be called a circle graph. And a circle graph typically displays percents rather than raw values. So we need to find something called the relative frequency for each of these colors. Relative frequency is found by taking the raw frequency divided by the total. So here 7 divided by 20 is 0.35. And we can convert that in, we could leave it as 0.35, or we can convert it into a percent of 35%. Well, blue is also 7 out of 20, so that's, again, 0.35, or 35%. And green is 6 out of 20, which is 0.30, or 30%. Now, these totals should add up. If I add up the percents, it should add up to 100%. Or if I add up the decimals or the rates here, they're technically, statistically, they're called a proportion. Those should add up to 1. Now, they may not always add up to exactly 1 or 100%, because if we're, here we divided by 20, so we're going to get nice even results. If it were 21 or some weird number, we get some weird decimals that have to be rounded. And sometimes we can be a little bit off because of the rounding. It could be 100.1% or 99.9%. because of that rounding, but we need to be really close to 100%. Now, back in the day when we were making a circle graph, our next step would have been to take that percent and find that percent of 360 degrees in the full circle, and then use a protractor to map it out. Well, now if we want to be that exact, there are tons of free software out there. Microsoft Excel does it very well. There's free downloads like Jamovi out there that do graphs as well. So all we really need to be able to do is to estimate. And our estimation really starts with the fact that a quarter of a circle is 25%. And so here we have the green that's 30%, so that's a little bit bigger than 25. Something like that. So that's going to be our green. And then, of course, red and blue, 35% each. So they're even slightly more larger than the 25%, or the quarter of a circle. Now here, because those are very close, 30% and 35% are not very far away, it is pretty tough to see the difference in the size of those slices. I mean, it'd be easier if we had, green was only like 10%, so it was a narrow slice, and then we had, other varying slices here. So in a lot of cases on a circle graph, we will still label those percents so that we can read it later. Now let's look at reading a circle graph. Because we're usually given percents, let's say that there's a total, that these percents still hold, and there's a total of 400 students surveyed. And I want to know how many shows blue. So what we would look at here for the blue, it's 35%. We have 400 total students. So I have to find 35% of the 400. So I can either set up the proportion like this, cross multiply and divide, giving me 140, or I could have done the rate method, taking 400 times 0.35, the rate for 35%, and getting 140 as well. Either way, 140 students chose blue. So reading a circle graph usually involves a little bit of an extra step if you want to get a raw frequency, because the circle graph just reports the percents in most cases. So like I said, I just wanted to touch on data graphs because I didn't feel right putting it on the test without mentioning them. But I believe you guys can take it from there and do what's needed. I won't ask you to construct any graphs, any data graphs on the test. You will have to graph equations on the test like we did most of last week. But for the most part, for data graphs, you're just going to have to read them and get the values off of the graph. The next thing I want to talk about then is formulas. Now again, many of you have seen these formulas before, and you're pretty adept at working with formulas even if you haven't seen them before. But I want to make sure I go through and we put all of the formulas that we're going to be using in this unit out there so that you have them. One that we've already used is the slope formula. And the slope formula says when you have 2 points, and I'm just going to label them x1, y1, and x2, y2, the slope, abbreviated m, is found by doing y2 minus y1. Remember, the difference in the y coordinates is the rise over x2 minus x1. So we've already done this a few times, so I'm only going to do one example here. If I have the points, let's do negative 6, 3, and 3, negative 3. And I want to find the slope. So I'm going to label these points 1 and 2. My slope, m, equals y2 will be the 0.2, the y coordinate is a negative 3, minus y1. Well, 0.1 y coordinate is a positive 3. I have to be careful with our negatives here. Negative 3 minus 3 is a negative 6. Then we have x2, so that's 0.2 x coordinate is 3, minus x1. So that's 0.1 x coordinate is a negative 6. Again, we have to be careful with the negatives. 3 minus a negative 6 is the same as 3 plus a positive 6, so that is 9. And then we reduce. Both 6 and 9 divided by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Now you may have noticed I kind of lost the negative there for a moment, because the negative doesn't have to go with either the rise or the run. It can be put out in front of the fraction like that. If both the rise and run are negative, of course, it would cancel out and give us a positive slope. Remember, we had mentioned when you have a negative slope like that, get back here, a negative 2/3 slope, we can either put the negative, we can leave the negative out front like that, or we can put it with the rise, or we can put it with the run, but we can't put it with both because two negatives, of course, would cancel out and make a positive. So if we were graphing that line, a negative 2/3 slope Apologize for the technical issues here today. Negative 2/3 slope could either be down 2 and over a positive 3, or it could be up 2 and back a negative 3. And you'll notice either way, that ends up being the same line. It just depends on what direction we go from our starting point. So based off of that, if we have x1, y1, x2, y2 points on a line on a graph. In fact, I just want to do a segment that connects those 2 points. The midpoint of a segment is the point, of course, that cuts the segment in half. Well, on a Cartesian graph or rectangular graph, that point, if I were to draw in my slope triangle here, my rise and my run, it's halfway up the rise and it's halfway over the run. So to get halfway up the rise, the coordinate, the rise of this one, this is at y1, this is at y2. To get the value that's halfway in between there, we take an average. So that would be y1 plus y2 divided by 2. And then the run, this point would be halfway between x1 and x2. Between those, again, it's an average. We add them together, x1 plus x2 divided by 2. So the coordinate of the midpoint, there's actually a separate formula for each coordinate. One formula combines the x coordinates to get the x coordinate of the midpoint, and the other formula combines the y coordinates to get the y coordinate of the midpoint. So if I have the point 7, negative 3, and 1, let's go 1, 11. And I want to find the midpoint. Well, once again, I just have to label them 0.1 and 0.2. And then I find the coordinate for the x coordinate of the midpoint separately. Then I'll find the y coordinate of the midpoint. So for the x coordinate, I take my 2 x coordinates of my points, 7 and 1, and I average them together. I add them together and divide by 2. So 7 plus 1 is 8, divided by 2 is 4. So 4 is the x coordinate of our midpoint. For the y coordinate, I take my 2 y coordinates. I have negative 3 and 11, so negative 3 plus 11 over 2. Negative 3 plus 11 is 8. 8 over 2 is 4. So 4 is also the y coordinate of this midpoint. So 4, 4 is the midpoint of that line. Now, since we've only just seen this formula, let's do a couple more examples. Let's find the midpoint between negative 7, 4 and 3, 12. So again, I'll label them 0.1 and 0.2. To find the x coordinate, I take the x coordinates, negative 7 and 3, and I average them together. Well, negative 7 plus 3 is a negative 4. Negative 4 divided by 2 is a negative 2. So the x coordinate of our midpoint is a negative 2. For the y coordinate, I take my y coordinates. I have 4 and 12. I add them together and divide by 2. 4 plus 12 is 16, divided by 2 is 8. So the y coordinate of our midpoint is 8. So our midpoint is at negative 2, 8. So in your notes, I want you to find the midpoint. Of the segment that connects these 2 points. 3, 8 and negative 5. Well, let's go to negative 5 too. I'll give you about half a minute, then we'll go over that. So we'll label the points point 1 and point 2. For the x-coordinate of the midpoint, we take the x-coordinates, 3 and negative 5, so it's 3 plus negative 5 divided by 2. 3 plus negative 5 is negative 2, and negative 2 divided by 2 is a negative 1. So the x-coordinate of our midpoint is a negative 1. For the y-coordinate, we take the y-coordinates, 8 and 2. We add them together and divide by 2. So 8 plus 2 is 10. 10 divided by 2 is 5. So the y-coordinate of the midpoint is 5. So our midpoint's at negative 1, 5. The next thing we need to be able to do is find the distance between those 2 points. So if this is my points x1, y1, and x2, y2 again, and if I put in that slope triangle again, this here is still the rise, and this is the run. But this is a right triangle, and we know, and the segment here would be the hypotenuse of that right triangle, where the rise and the run are the legs of that triangle. So we know that we can find the hypotenuse of a right triangle using that old formula, the Pythagorean formula, a squared plus b squared equals c squared, where a is the rise and b is the run, and c is our distance between the points. So to rearrange this a little bit, the rise is the difference in the y-coordinates. The run is the difference in the x-coordinates. Now typically we put the x-coordinates first. So it'll be x2 minus x1 and squared, that's the run squared, plus y2 minus y1, that's the rise squared. And then to get the hypotenuse, or that distance, call it d. We put it in front instead of in back. And rather than writing it as d squared, we take the square root of the other side. So the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So again, let's look at that as it relates to some points here. Let's do 5, 2, and let's do negative 3, 17. So I've got points 1 and 2. My distance will be the square root of x2 is negative 3 minus x1 of 5 squared, plus y2 is 17 minus y1 of 2, and that'll be squared. So now it's a matter of running through the formula. We'll do this formula by hand, but then we'll come back after this. We will use the calculator for it. Negative 3 minus a negative 5 is a negative 8 squared. 17 minus 2 is 15 squared. Negative 8 squared. Now here's where you have to be careful on your calculator. We've looked at this before, where if you're not careful with the calculator, if you just type in negative 8 squared, it's going to give you a negative 64. Remember, calculator does strict order of operations. It applies the squared first, then puts the negative on. To square that negative 8, we have to put the negative 8 in parentheses and the squared outside the parentheses to get 64. Always remember that when you square something, the result is always positive. The negative 8 squared is 64. 15 squared is 225. 64 plus 225 is 289. And the square root of 289 is 17. So the distance between those 2 points on the graph is 17 units. Whatever the units are between the coordinate points, that's the units for the length of that segment, or the distance between those points. Let's do another one. Let's find the distance between the points for negative 3 and negative 2, 5. So our formula here, that distance, to the square root of, I'm going to call this point 1 and point 2. So x2 is negative 2 minus x1 of 4 squared, plus y2 of 5 minus y1 of negative 3 squared. So we're just going to go ahead and put this in the calculator to show you that it does all come right out in the formulas. So second square root, we got to remember to put that in first. Negative 2 minus 4, okay. Now do parentheses, negative 2 minus 4, close the parentheses and squared, plus parentheses, 5 minus a negative. Now, remember to use this key down here for negative. Don't use your minus key. Most of your calculators do have a separate negative key. Minus negative 3, close parentheses and squared. And then on my calculator, I don't have to close the square root because it puts it under the square root symbol. On many of your calculators, you will have to do a close parentheses to close the square root. I had equals, and I get 48, and I see that I entered that incorrectly. I got the wrong symbol here. That should be plus there. There we go. 10 is what I was looking for as my answer. So the distance between those 2 points is 10 units. Now there's a lot more we can do with those. We'll come back to that more if we have time at the end. We only have about 15 minutes left. And so I promised I would take some time to go over the parallel and perpendicular lines a little bit more. So I want to do an example of each of those and then review a little bit of that variation stuff for the test. And then if we have time, we'll come back. We've covered everything that's going to be on the test for the midpoint and distance formulas we've covered so far. But I want to look at how would you go backwards? How would you find one of the endpoints if you needed to? Anyway, so let's take a peek at they're trying to get a new computer set up here, and some of the settings are still a little jumbled on me. So find the equation of a line parallel to y equals 3/4 x plus 2 and through the point 8, 1. So here we have this equation given, y equals 3/4 x plus 2. The only piece of information we want from that equation is the slope, right there, the number that multiplies x. 3/4 is our slope. Now the parallel slope, if you recall from the last couple of classes, is the same. So the slope of the parallel line is also 3/4. So our equation of our line here starts out as y equals 3/4 x plus b. A review, remember the form of the line is y equals mx plus b, where m is the slope and b is the y-intercept. To find b here, we use our point that it goes through, putting in 1 for y, and 8 goes in for x. So now we have to combine 3/4 times 8 is 6. And then we'll solve for b by subtracting that 6. So 1 minus 6 is -5. So b equals -5. So that means we can come up to this equation up here and we can replace b with -5. So y equals 3/4 x. And instead of plus b, we're going to put in -5. So you could either put in plus a -5 or just -5. Either one would be accurate there. We could be asked to find the equation of a line perpendicular to y equals 2/3 x minus 3 and through the point 6, -2. So once again, from this equation here, the only piece we want is the slope. So our slope is 2/3. Now remember, the perpendicular slope is going to be the opposite reciprocal. So first, opposite. That means if this is positive, it's going to become negative. If it was negative, it would become positive. Well, this slope's positive, so we're going to become negative for our slope. Reciprocal means A over B becomes B over A. We just exchange the numerator and denominator. In this case, we exchange the rise and the run. So this was 2 over 3, it becomes 3 over 2. So our perpendicular slope is a negative 3 over 2, telling us that our equation starts out as y equals negative 3 over 2x, and again, plus b. And again, we'll find b by putting in that point that it goes through, 6, negative 2. So y would be the negative 2 equals negative 3 over 2 times x would be the 6. Excuse me. Be very careful with your b's. It's real easy for a b to look like a 6. You notice I try to exaggerate it a little bit so it looks boxy. But I have seen students make that mistake a few times. So anyway, now we have to combine. Negative 3 halves times 6 is a negative 9. So negative 2 equals negative 9 plus b. And to solve for b, we add 9. So negative 2 plus 9 is 11 equals b. So up here in this equation, b is negative 11, or is positive 11. So that becomes y equals negative 3 over 2x. And instead of plus b, we put in plus 11. I want to take a minute to look at, wrong mouse, that's why it's not working. To review some of the variation type problems that we looked at last class, since we had a few people gone. So let's look at a problem like the amount of medication required varies directly with the patient's body surface area. For a patient with BSA of 1.2 meters squared, we administer 48 milliliters of medication. How much medication should be used for a patient with a BSA 0.9 square meters? So here, the big thing is it varies directly. So the amount of medication varies directly with the body surface area. So we're going to let B be body surface area, M be medication. So M equals a constant times the body surface area. Medication equals a constant times B. That is the definition of a direct relationship. Then remember we have that known condition. A patient with a body surface area of 1.2 square meters gets 48 milliliters of medication. So we plug that in. The 48 is M, so that goes in for M. 48 equals K times 1.2. And we solve for K by dividing by the 1.2. And so 48 divided by 1.2 is 40. So 40 equals K. So it allows us to define this relationship further. Instead of just M equals a constant times the body surface area, M equals 40 times the body surface area. And then it wants us to extend that to a new condition. How much medication for a patient with a body surface area of 0.9 square meters? So M equals 40 times 0.9. Give us 36 milliliters of medication. The important thing is to make sure that the units we use for body surface area, not for M here, both of those were in the same units. They were both in square meters. And so then we need to make sure that our results, the medication here was in milliliters. This medication also has to be in milliliters. So that's an example of direct variation in practice. Let's look at an example of inverse variation. At a constant temperature, now that might not always be stated, but it is assumed that the temperature stays constant if nothing is said about it. But I'm going to explicitly state it here because we talked about that a little bit on Wednesday. At a constant temperature, the volume of a gas varies inversely with the pressure it's under. We'll say with the pressure it is contained in. Should have said in which it's contained, but this isn't a grammar class, right? If a gas at, let's do 12 psi has a volume of 36 cubic inches, find the new volume if the pressure is increased to 18 psi. So inverse relationship, remember, that means that when one number gets bigger, the other gets smaller. So if we're going to use V for volume and P for pressure, varying inversely, the volume equals a constant divided by P. But remember, up here, direct variation, it was one variable equals a constant times the other variable. Here for inverse variation, it's one variable equals a constant divided by the other variable. And then, of course, we have that known condition. The gas at 12 psi has a volume of 36 cubic inches. We put 36 in for volume, K over 12, and now we solve for K. The K by itself is being divided by 12, so we're going to multiply by 12. 36 times 12, I believe that is 432. Okay, let me double check that quick. It is 432. So that allows us to further define this formula here by replacing K with 432. So the volume equals 432 divided by the pressure. And then it does ask us to extend to that new condition, that new instance where we have pressure of 18 psi. Volume equals 432 divided by 18. And so we just do the division. 432 divided by 18 should give us 24. And it does. So that'll be 24, and of course the units of volume are cubic inches that are being used in this problem. Now, one thing to note when we're dealing with inverse variation, we could have, let's say, same situation. So we get that formula, the volume equals 432 divided by the pressure. And I ask, what pressure at what pressure would the volume be 8 cubic inches? So I put 8 in here for V equals 432 over P. Now we're solving for a variable that's on the bottom of a fraction here, and that's not easy to do. So the simplest way to do that is to turn this into a proportion. So we put the 8 over 1 so that we can now calculate by doing a cross multiply and divide. 1 times 432 is 432. Then we divide by the 8, which is going to give us 54. So that pressure would be 54 psi. Okay, so we are pretty much out of time. We only have 1 minute left, which is okay. Doing the reverse calculations with the midpoint and stuff is not on the test. It's just an interesting calculation to do sometime. Anyway, your homework for today, there is not a page out of the book for this. So there is a worksheet attached in Blackboard. And that worksheet goes over the formulas, and it goes over the parallel and perpendicular lines. With that, I will be sending out the test to your contact people at your school later today, so they will have it for you. If you think you're going to need more time on this test, I mean, it is a little bit of a lengthy test, but this should all be material that you've seen before. But if you do think you're going to need more time, you are welcome to start it early. I will make that note when I send it out so that your contact people can make that happen if you want to. With that, you all have a great weekend, and hopefully we'll see you all back here on Monday for the test.